Welcome back to learning program Cisco Networking with Rajput. Today we are going to have a look at BGP Route Reflector. This is widely implemented solution. This solution is amazingly easy to implement. Basically what we do, we define some BGP speaking devices as route reflectors in our network and others as route reflector clients. When we introduce new device in network, what all we need to do is to have an eBGP session with route reflector and we are done. So from a network connectivity point of view, we can have three type of network connectivity with our route reflector device. One, we have route reflector clients. Two, we have route reflector non-clients. And third is eBGP peers. So accordingly, we have some rules which are followed while advertising or relaying the information from one peer to another BGP peers. So the first rule is advertisement from clients will be advertised to clients, non-clients, and eBGP peers. Second rule is advertisement from non-clients will be advertised to clients and eBGP peers only. Third rule, advertisement from eBGP peer will be advertised to both clients and non-clients. So if we see the big picture, basically what we are doing with the help of route reflector is we are just ignoring the BGP rule of a split horizon only for some specific iBGP peers, and those specific iBGP peers are route reflector clients. So whenever we are talking about the advertisement to route reflector clients, route reflector will just ignore the BGP rule of split horizon and it will simply relay the information which it has got from one iBGP peer to another iBGP peer. So this is the only thing which makes the difference. Like in any situation, any BGP speaking router, when it gets any update from eBGP peer, it will always relay that information to all its neighbors. So the same thing is happening over here as well. Advertisement from eBGP peer will be advertised to both clients and non-clients. So this is normal. So the next situation is where the advertisement comes from non-clients. See what happens that uh, there are, if we have two non-clients, then the BGP rule of split horizon works, and if one non-client gives some prefix to RR, then RR will simply follow the BGP rule of split horizon and it will not relay the information to another non-client. So in this case, the only devices which will not get the updates from RR, or the RR will follow the BGP rule of split horizon, will only apply to non-clients. Okay, so let us see some route reflector functions. It sets the originator ID if the ID is already not there. Route reflector only reflects best routes to clients and non-clients or eBGP peers. It doesn't make any change in advertised prefix attributes. All the traffic from clients, non-clients doesn't traverse through route reflectors. It just advertises the prefix to client/non-clients, and all the routers do their own lookup for the next hop. Something about route reflector cluster ID. So a BGP cluster ID is 4 bytes. RR and its clients share the same cluster ID. If cluster ID is not set, RR will take BGP identifier as cluster ID. It's a BGP's loop prevention mechanism. Whenever RR reflects any prefix, it adds its own cluster ID, and if it sees its own cluster ID in some advertisement or in update, it will simply ignore that update. It will not update its own routing table because it understands that its own cluster ID is there. That simply means this router already has that particular prefix. So that's why this is a loop prevention mechanism, and RR will not consider that update. Now let us have a look at the scenario today we are going to use. We have RR, and these two are backbone routers, and this is route reflector client, reflector client 1, route reflector non-client, route reflector non-client 1, and eBGP peer 1. So these are the prefixes. 10.1.1.2/32 is used for iBGP peering. In the same way, dot 3 is used for iBGP peering 4, 5, and these both of these neighbors are having eBGP peering, so that is on physical interfaces. 2.2 is advertised from RRC, 3.3 is advertised from RRC1, 4.4 from non-client, and 5.5 from non-client 1. In the same way, 6.6 eBGP peer and 7.7 eBGP peer 1. So let us go and check the devices. Okay, so this is how the physical connectivity is, and I have put the description as well, which interface goes to which router. Let us start configuring BGP for all the neighbors. So this is part of AS100, RRC, RRC1, non-client and non-client 1 are all part of AS100. This eBGP peer is part of AS200, and this eBGP peer 1 is part of AS300. Accordingly, we will configure. This is for 3.3 or 10.1.3 for RRC, and now 4 and 5. Four and 5. So let us go and configure eBGP with RR. So 18.118, neighbor 18.118, remote is 200, neighbor 19.119, remote is 300. On backbone routers, I have just enabled the MPLS IP on the interfaces facing on all its interfaces on backbone router and backbone router 1, and on RR I have enabled MPLS facing backbone interfaces. So that simply means on these interfaces I have enabled MPLS. Now let us go router BGP. (100) neighbor 10.1.1, remote is 100. Update source, loopback 2, next hop self, and network statement. Show history. Let us go to RRC, copy. Oh, control home. Come on. Remote AS is 100 and network is 6.6. Go on. Adapter BGP 300, neighbor is 90, remote AS is 100, network is okay. So now we have basic BGP configuration and I see all the BGP sessions are up now. Let us configure Route Reflector client now. Show run section router BGP. Okay, so in our design, what we have RRC and RRC1 are clients. So let us go and configure. Neighbor 10.1.2 Route Reflector client. So you see that whenever we configure the some iBGP peer as Route Reflector client, it simply resets the BGP. That's simply because it sets its own environment, like just to avoid the iBGP rule BGP rule of split horizon. So for that, it just resets the session and re-establish the session. So now we see we have all the sessions of show BGP summary. Okay, we have all the sessions of summary. Okay, we see to show IP route BGP. Okay, let us do a trace for 2 source loopback. One, we can reach from eBGP peer 1 to RRC. So our network connectivity and advertisement is good. Now the important thing is we need to check what all prefixes clients are getting, what all known clients are not getting or getting, and eBGP peers, what all prefixes eBGP peers are getting or not getting. So if you see, we have 2, 3, 4, 5 and 6 subnets. 2 is advertised from RRC, 3 is advertised from RRC1, 4 known client, 5 known client 1 and 6 eBGP peer. So this eBGP peer has complete advertisements from clients, known clients and eBGP peer. So this is a standard BGP. RR didn't make any changes to in the case of eBGP session, because in the case of eBGP, what all advertisements or best path any router has, it simply relay the complete information to eBGP peer. So that is happening here as well. So now let us go to RRC and see what all prefixes RRC can see. RRC do show IP route BGP. It has got 3, 4, 5, 6 and 7. 3 it has got RRC has got 3, 4, 5, 6 and 7. 3, 4, 5, 6 and 7. So it has got 3, 4, 5, 6 and 7. In the case of Route Reflector client, it is getting the complete routing table. It knows about the client, its own iBGP peer, which is the information is getting relayed from RRC1 to RR and then to RRC. So RRC knows about its own iBGP, iBGP peer without having direct iBGP peering with RRC1. And on the other hand, it knows about the known clients. Both the known clients 4.4 and 5.5 are being advertised to RR, and RR relays the same information to RRC. So that simply means clients will have the complete picture. It will have the complete updates from RR. Now let us go and check the known clients. RRC known client do show IP BGP, do show IP route BGP. So now it has 2, 3, 6 and 7. 6 and 7 are route reflector is getting from eBGP, so that will definitely be relayed to any peer. So that's natural. Now let us check at 2 and 3. 2 and 3 are advertised from clients RRC and RRC1. So what happens? The BGP rule of a split horizon is ignored. The updates from clients coming to RR are relayed to known clients. But what is missing on known client is that uh, we have two known clients 4. One is advertising 4.4 and another one is advertising 5.5. So we are checking on known client and we do not see any routing, any route for 5.5. See, we do not have any route for 5.5. So that simply means the BGP rule of split horizon works in this case. And if known clients have to have the complete routing table, they must have full mesh BGP peering with all the known clients. Then only they will have the complete routing table. Otherwise, known clients will not get any update of other known client. So this is the beauty of Route Reflector. I hope you find my video informative. If that's so, please don't forget to like, share and subscribe. Thank you for watching. Hope to see you again.